Hi guys, I'm Lynette Benitez, your tutor for today in physics. But before we start in the discussion, let me discuss to you the objectives and key terms of our discussion. Our objectives are: first, understand the concept of free fall motion; second, solve the basic problems concerning with free fall motion. The key terms of our lessons. Key points: the acceleration of the free-falling objects is called the acceleration due to gravity, since objects are pulled towards the center of the Earth. The acceleration due to gravity is constant on the surface of the Earth and has the value of 9.80 meters per second squared. And the key terms: acceleration, it is the amount by which speed or velocity changes with a certain period of time. Our topic for today is free-falling bodies. So what is free fall? Free fall is the motion of a body where its weight is the only force acting on an object, while free fall motion is the downward motion under the influence of the gravity. In other words, when the only force acting on an object is gravity, the object is said to be in free fall. Just only remember the word downward motion when we define free fall motion. So, the motion of free-falling objects is the simplest and most common example of motion with change in velocity. So, we have the two figures. In figure A, if a coin in a feather simultaneously drop in airfield, the feather takes much longer to hit the ground. However, if in figure B, if a coin and a feather are dropped in a vacuum area, it will look like both the coin and the feather hit the ground simultaneously. It is due to the amount of force acting on an object is a function of not only its mass, but also in the area. Galileo also observed this phenomena and realized that it disagreed with the Aristotle principle that heavier items fall more quickly. And Galileo then hypothesized that there is an upward force exerted by air in addition to the downward force of gravity. So, if air resistance and friction are negligible, then in a given location, all objects fall toward the center of the Earth with the same constant acceleration, independent of their mass. That constant acceleration is gravity. As we said earlier, gravity varies depending on location and altitude on Earth. But the average acceleration due to gravity on Earth is 9.80 meters per second squared. This value is also often expressed as a negative acceleration in a mathematical calculation due to the downward direction of the gravity. The acceleration of a freely falling body is called the acceleration due to gravity, and its magnitude without any algebraic sign is denoted by the symbol d. So, the acceleration due to gravity is directed downward toward the center of the Earth. Near the Earth's surface, g is approximately, unless circumstances warrant otherwise, we will use either of these values for g in subsequent calculations. In reality, however, g decreases with increasing altitude and varies slightly with latitude. So, free fall is closely approximated for objects falling near the surface of the moon where there is no air to retard the motion. A next demonstration of lunar free fall was performed by astronaut David Scott, who dropped a hammer and a feather simultaneously from the same height. So, this is what the astronaut David Scott did in a lunar where both hammer and the feather was dropped simultaneously. Both experienced the same acceleration due to lunar gravity and consequently hit the ground at the same time and at the same height. The acceleration due to gravity near the surface of the moon is approximately 1/6 as large as that on the Earth. Air resistance opposes the motion of an object through the air, while friction opposes motion between objects and the medium through which they are traveling. The acceleration of free-falling objects is referred to as the acceleration due to gravity. So it means that air resistance and friction must critically play the role in free-fall motion in which they are traveling, and to find the motion or the movement of the falling objects, and the and the acceleration due to gravity is constant. The best way to see the basic features of motion involving gravity is to start by considering straight up and down motion with no air resistance or friction. So this means that if the object is dropped, we know the initial velocity is zero. Once the object is in motion, the object is in free fall. Under these circumstances, the motion is one-dimensional and has a constant acceleration g. So in the first velocity, we have a zero since it is a potential energy, and once the motion is in motion, then it is a kinetic energy. When the equations of kinematics are applied to free-fall motion, it is natural to use the symbol y for displacement since the motion occurs in the vertical or y directions. So here are the kinetics formula or equations in free-falling bodies. In first equation, changes in velocity is equal to velocity final minus velocity initial is equal to change acceleration to the gravity multiplied to changes in time. Second equation, changes in displacement is equal to 1/2 multiplied to velocity final plus velocity initial multiplied to changes in time. Third equation, changes in displacement is equal to velocity initial multiplied to changes in time plus 1/2 multiplied to acceleration due to gravity multiplied to changes in time squared. Last equation, velocity final squared minus velocity initial squared is equal to 2 multiplied to acceleration due to gravity multiplied to changes in displacement. Y is equal to negative 9.8 meter per second squared. We now turn our attempt to examples that illustrate how the equations of kinematics are applied to freely falling bodies.
Ang problem na sasagutan natin ngayon ay tungkol sa free-falling objects. Pag sinabi nating free fall, it is the downward movement under the influence of gravity only. Ibig sabihin, tanging gravity lang ang dahilan ng pagbagsak o pagkahulog ng isang bagay. Sabi dito sa problem natin, meron daw tayong bola na iniagis mula sa taas ng building sa bilis na 12 meters per second. Ang tanong, gaano daw kabilis yung bola nung pabagsak nito sa ground? Para malaman natin yan, kailangan muna nating alamin kung gaano ba kataas yung naabot ng bola mula sa ground. At dahil given yung height ng building, itong height na lang natin yung hahanapin natin. Meron tayong kinematic equations dito. At dahil hindi given yung time, itong equation na ito yung gamitin natin. Final velocity squared is equal to initial velocity squared plus or minus 2gs1. Ngayon, yung bola, habang umaangat, nag-decelerate yan dahil hinihila ng gravity hanggang sa mag-zero yung final velocity niya. Ibig sabihin, yung final velocity natin dito ay 0. So, initial velocity squared minus dahil nag-decelerate, bumabagal habang umangat. Lipat natin sa kabila. Divide natin. Itong 9.81 meters per second squared na to, dito yung acceleration due to gravity. At ang S1 natin ay 7.34 meters. Ngayon, i-add lang natin to dito sa height ng building. So, ang naging S natin ay 60 meters plus 7.34 meters. Sagot, 67.34 meters. Ngayon, nakuha na natin tong height na to mula dun sa naabot ng bola hanggang sa ground. Nahanap na natin yung final velocity ng pagbagsak ng bola sa ground. Itong equation pa rin natin yung gagamitin natin. Plus, dahil nag-accelerate na yung bola pababa, nila na ng gravity. Yes. Ito na ngayon yung magiging initial velocity natin. 0 yan. Plus 2 times 9.81 meters per second squared. At yung S natin, ito, 67.34 meters. Square root natin. At ang final velocity natin ay 36.35 meters per second. Ayan, nakuha na natin yung final velocity. Ito yung bilis ng bola ng pabagsak na siya sa ground. Sana nakatulong sa inyo yung video na to. Maraming salamat.
So, thank you for watching. I hope you enjoy and learn to my video lesson topic about free falling bodies.